Actually, I have a lot of envy for the presentation that we have just seen because of the technicalities of it. I'm afraid I'm not going to speak about so much technicalities, and as engineer, I really miss them, but about the part of the game, the policy part of the game. I'm Luis Busquets, and I'm working for the European Commission in the Cloud and Software Unit. As public administration, you would wonder what we are doing here, actually. We, as the European leading at public administration, have an interest in the European citizens, have an interest in having an economy that works for the citizens and that, of course, creates jobs and opportunities. And because of that, we have an interest in ICT as a competitive tool that can bring more opportunities to citizens. In this sense, we have set high ambitious targets for ICT in Europe. The Digital Decade Objectives for 2030 includes more than 10,000 edge nodes and more than 75% of companies connected to cloud computing. Actually, we are not the only ones to understand that ICT, computing, processing is important in Europe. Member states alone have already presented an important project of common European interest, putting 1.2 billion euros for ensuring and enabling a truly interoperable European cloud. That basically to overcome technological dependencies that exist. And that is certainly the reason why I am here, because RISC-V is seen as a key to ensure that there are no barriers for innovators in Europe to actually develop tools and services that citizens can use. And of course, we do work on legislation to ensure that this happens, but we also fund programs in order to make it happen. It's not only that we believe that an important European industry is something crucial, but also because, well, European values are not necessarily shared by the whole world. And by having European technology, we can be sure that how we see privacy, how we see security is actually implemented through technology. But anyway, we are interested in the ICT market because it's not a small market. It's not a small part of the economy. More than 44 trillion euros at world level prove the importance in today's economy. However, there would not be this 44 trillion if we did not have the technology of semiconductors. At the core bottom of this pyramid, we see how semiconductor development enables and gives tools for services and for telecommunications to happen. I particularly work in the cloud and software unit, and in the cloud and software unit, we need to produce cloud services that are consumed by citizens, and for these cloud services to be consumed, we do need cloud infrastructure. And what it means, cloud infrastructures, it means actually data servers. Data servers, the computation that is powered by processors. The bad news for Europe is that, at least nowadays, we are not really digitally autonomous in terms of processing. And what's more, if we speak about processors worldwide, we realize that, well, surprise, surprise, more than half of the market for processors is used for computation. So basically, the computation networks that we're going to install in Europe, well, the vast majority, if not all, except prototypes, will be based on technology not developed in Europe. But anyway, we have tools and methods to ensure that there is competition in the market and that there are also opportunities for citizens and for companies in Europe. And actually, here comes precisely what we learned from the last study on open source. The study on the economic impact of open source software and hardware in Europe demonstrated that first there was a huge impact of open source. There was a confirmation that open source helped actually the economy, and not only that, but opened barriers, removed barriers, represented a level playing field for companies, represented also good investment of cost benefits more than 1 to 4, and a big impact in the economy, also correlating to the growth in the economy. Actually, the understanding of open source has changed quite a lot. Back from 20 years ago, when we regarded as everything that was open source as something competing with closed source software. Now we realize open source of not just software but hardware, and not as something competing but actually as a public good. Which means that, well, in the same way as you can have a fountain in a village getting water, you can get open source assets either in the field of software or hardware or ISAs that are open source, basically available for you and for whatever you want to do, either for you, for your company, or to sell to others, or to keep it for yourself. And that certainly represents a very nice tool to ensure one of the key things that my commission is seeking, that is digital autonomy. Digital autonomy, that doesn't mean that Europe is alone in the world or that has to act alone in the world, but it means that the Europe has got the possibility to act alone if it is needed in the defense of its values and principles. We are here in a RISC-V summit, and RISC-V is important first because it's open source, which means that basically we will be able to use open source for whatever we want. But anyway, if we speak about the big ICT picture, what we see is that people do not really buy silicon. What they buy as services in terms of telecommunications, in terms of computing services, in terms of things that actually have a use for themselves. And actually RISC-V is integrated, and processing is integrated in the whole and large scale on it. Actually, this slide is actually biased on purpose. While we see that the development of RISC-V of a chip includes a logical level, a component level, even a volume, a module level. Actually, if we do not have the application level at the site, it is not worth for the economy. We need to have applications for have something that is interesting. And actually, the big part is the final part, but we cannot have the final part without completing everything. And here is precisely where open source will help us, because the open source communities have managed to create an open architecture from the kernel up to the application level. However, below it's still closed, waiting for what happens with RISC-V, of course. The Commission is investing quite a lot in ICT, and not only the Commission, but also member states are doing it through the IPSE, as I said, but also we are investing with InvestEU and with the regional funds on different initiatives. But anyway, the Commission is also investing in ICT directly through 3 different programs: the Research Framework Program, Digital Europe for implementing the results of research, and Connecting Europe Facility. In particular, when we are faced to bring digital autonomy to cloud computing, what we are faced is to make sure that European technology can power cloud computing infrastructures. And because of that, we had to start thinking about what we had. And 4 years ago, what we had is basically, well, developments in processors. We were funding the European Processor Initiative for supercomputing. We were also seeing how the number of devices throughout the world connected to the internet is exponentially increasing, and we're expecting more than 100 billion devices, all with its own processor by 2050. Sorry. And we also had a cloud value chain that started from raw material But if you don't reach the application, well, sorry, but you're nowhere. So actually, you have to make sure that you complete all the steps. Thankfully, open source was covering a big part of it. So the missing part is precisely at the low level, and the processor is one of the issues that we see to ensure that Europe has got alternatives. That's the reason why in the Research Framework Program, already in 21-22, we started investing in how to get the results of the European Processor Initiative into cloud infrastructures. Probably at that time, of course, the developments were still at a certain stage, and because of that, we funded two kinds of initiatives. First, those who were trying to build hardware and to build cloud infrastructures, implementing new processing architectures, that at that time, it was not only RISC-V we were referring, but other new that could help, and also virtual environments that allowed to test the whole open source stack so that to make sure that whenever we had the hardware platform, we already had got the software tools that deliver the services that are the ones that are needed. We have continued in 23-24 also, and we are going a step further. If first we just wanted to make sure that cloud infrastructures, basically the data centers, the servers at the data centers, had got European technology in it. Now, with the conversions of cloud edge networks, what we are pushing is for European technology throughout cloud edge. Actually, there are a number of processors that are being developed through the European funding. The main sources, of course, is the Research Framework Program with the EPI processors, the EPAC 1.5 and 2.0 that will be in 2020 and 25. The REA 1 and the REA 2 that is also in the kitchen. And through the EU pilot, we're also going to develop 3 more processors. But the Research Framework Program is not the only way how it is funded. As I thought, it's not only through direct investment that the European funding is coming, but also let me just point to the project DRAC, which is using regional funding to develop 2 processors, also based on RISC-V, and actually a third one which is being developed. And also through the Next Generation EU, we are funding the e-processor initiative for actually bringing more possibilities to the citizens. And what is the future to come? Well, now, at this point, it is in a high political agenda, the convergence between communication and information technologies. And because of that, the discussion is on whether there is a need for a large-scale pilot which deals with the connected collaborative computing networks. That's what we call the 3C networks. Of course, this large scale pilot would include telecommunications development, the telco edge cloud, the adoption and the development of a sovereign telco edge cloud technologies in the EU, but also will need to coordinate to make sure that the underlying technology that is powering the telco edge is including also the results of processing development in the cloud edge infrastructures. Actually, the 3C supply-side pilot would cover computing throughout, throughout the telecommunications landscape, from on-premises to near and far edge, and of course in the data cloud, in the data center. But anyway, what is important, I believe, for the RISC-V summit is precisely to speak about how RISC-V can be integrated also in 3C by creating EU sovereignty in a market that may be shifting from a telco equipment to IT equipment where there are not really EU alternatives. While in the telco equipment manufacturers, we have very strong competitors in Europe, maybe that's not the case if we move to the IT equipment. And therefore, the extension of an open computing architecture may be even more important, because we would pass, in case this did not happen, to a case of increased dependency. And anyway, what is important is to also bring the synergy that we have with other projects, including the Euro HPC and also others who are developing processors. And finally, let me remind you that we've spoken about processors and the importance of processors in networks, but that our final outcome concerns a very high level, which concerns to have a data economy that works for citizens. And because of that, well, many policy initiatives are not only being taken at the processor level, but at high level. But this high level will never happen if you do not have digital autonomy for processing. And of course, have good luck in case you decide to execute any software without a computer. That was. Thank you.